Welcome to this webisode for separation processes, where I'll run through the solutions to class test 2. So the first question for class test 2 was a single stage liquid-liquid extraction in which 400 kilograms of a solution that's 35 weight % acetic acid in water is mixed with 400 kilograms of pure isopropyl ether, and you're asked to calculate the amounts and compositions of the extract and raffinate layers, and you're also asked to calculate what % of the acetic acid is removed from the feed. First stage is to draw a diagram. So here's a generic diagram of a single stage liquid-liquid extraction, and if we list the data, we're given the feed amount and the feed composition, L0 and X0, and we're given the solvent, fresh solvent amount, and it's pure isopropyl ether, so it has mass fraction of 0 acetic acid. The only assumption that's necessary to solve this problem is that V1 and L1 leave the stage in equilibrium. So the first step in the analysis is to complete the total and the component mass balances. This allows us to calculate that the mixture amount is 800 kilograms and that the mixture composition is 0.175. The second step is to locate the mixture point on the equilibrium diagram. So first we draw in the mass balance line between our pure isopropyl ether solvent and our feed, which is 35 weight % acetic acid in water, which must be 65 weight % water. We know that our M mixture composition is 0.175 acetic acid, so coming up from the acetic acid axis, we know that the mixture point is going to be just there. And by reading off the other diagram which was provided, which was the partition distribution of acetic acid between the two phases, we can construct the tie line that passes through point M. That looks like this, and that gives us the compositions of the raffinate and the extract 0.255 and 0.11 respectively. The fifth step in the analysis is to calculate the amounts of the raffinate and extract. So we take those compositions and we substitute them back into the component mass balance and the total mass balance. We have two equations with two unknowns, L1 and V1, so we solve them simultaneously to obtain the amounts of the raffinate, 358 kilograms, and the extract, 442 kilograms. And just as an internal check of consistency, those two should add up to 800 kilograms, which was the mixture amount. The last part of the question was to calculate the % of the acetic acid that's removed from the feed. So that is just the composition of the extract multiplied by the extract amount, which is 442 kilograms, divided by the composition of the feed multiplied by the feed amount, and that's 0.347. So stating those answers, we can write out what the raffinate and extract amounts and compositions are, and that the % removed is 34.7%. Question 2 is a simple example of equimolar counter-diffusion. So we have ammonia diffusing through a tube that's 0.1 meters long, contains nitrogen gas at this pressure, and we're given the partial pressures at 0.1 and 0.2 and the diffusivity of A and B, so the diffusivity of ammonia in nitrogen. We're asked to calculate the steady state flux. So if you want, you can draw a diagram. It's the same as the one from the question statement. There are the key pieces of data summarized from the problem statement. The only assumption that we need is that it's at steady state and that we have equimolar counter-diffusion. And so the analysis is simply to substitute all of the known values into this expression to calculate the flux. And the answer is that the flux at steady state is 4.7 by 10⁻⁷ kilomoles per meter squared second.